Okay. So any questions on 13? 13's okay? Yes? Okay. The next questions were 18 and 19, right? Which we skipped for right now. And so then what was the next number I need to show you? 28. All right, so there's a few more. You can see like 28 through most of 33. There, now you can see 28 through 33. Can you read those? Are those okay? Oh yeah, that's pretty big. Any issues in there, things you're going to want clarification on when I go back to the problems themselves?
How do you do that?
How do I do what?
That in general. Like, I have no clue how to do that.
I don't know what that
Like the
is.
exponential growth, decay,
Which problem number are we talking about?
any
28? This section. Okay, that's fine. I'm just looking for like a polite and specific way of asking something instead of like a angry as if no one's ever taught you anything sort of question. So just polite and specific is all I'm looking for. All right, so we'll take a look at that section when we go back to the problems. Any questions about 33? We're good? All right, let's look at 39. Question?
So if I got 32.
What came after the 2 in your calculator? 88. So we have to round appropriately. So we just want to be careful. Sometimes I find students have gotten in the habit of just like hacking off numbers, but we're in math class. We round appropriately, right? So if it ends in a 2, but then after that is an 8, we know we need to round up. Okay? And if you gave me 0.88, like I'd be fine with that, right? Because this is a money problem. So unless it said round off to the nearest dollar, I would probably expect that you would have rounded off to the nearest penny because that's usually how we do money. So I would accept rounded off properly to the nearest penny or rounded off properly to the nearest dollar. I don't remember what the actual direction said. Any questions on 39? Or we can go back and look at growth and decay and then talk about compound interest. We're good? We're ready to go back? Yes, no. I don't know where we're at because I can't even seem to get a head nod. We are great. Okay. So let's go back and look at the problems. We'll look at growth and decay, and then we'll talk about compound interest. All right. So if I have something like y equals ab to the x, right? That's an exponential function. We worked on that yesterday in class. And when you did all those word problems, you at first were always given the equation, right? And then we had those challenge problems in your what to do where I came around and worked with each group on at least one of those. And we talked about how the b value is created, right? And then you did an activity last night in Google Classroom where you looked at what happens when b changes. And I asked you to look at b basically in two situations. Either a situation where b is bigger than 1 or a situation where b is less than 1. Show me in the air. When b is bigger than 1, what does a graph do? Just trace it in the air. Yeah, it goes like this, right? When b is bigger than 1, the graph goes like that. When b is less than 1, what does the graph do? Yeah, it goes like this. Right? Okay. So we read graphs from left to right just like we read words from left to right. So if I'm reading the first graph from left to right, would you say it's increasing or decreasing as I read from left to right? So the graph on the left is getting smaller as we go from left to right? The only left. No, I'm looking at this picture. This picture. It's going up, right? This is increasing. So if we describe something as either growing or decaying, which word makes more sense to go with increasing, growth or decay? Growth makes more sense, right? So this type of graph would be a growth graph. Now this one, as we read from left to right, would you say it's increasing or decreasing? It's decreasing, right? It's getting lower and lower, closer to the x-axis. So if the other one's growth, this must be decay, right? If you think of like leaves decaying in the yard, right? If you imagine in the fall when you like have to rake all those leaves and you have a big pile, If it snows on those leaves before you like get rid of them, what happens to the leaves in the spring? Are they a big pile? No, they're like flat, right? So the height of the leaves has lessened, right? The height has decreased over the winter as it first got just squashed by the snow and then started to decay because they were like wet leaves. Okay, so decay makes something less, growth makes something more. So that's what we saw when we looked at that Google Classroom activity last night. Now, if we didn't do the Google Classroom activity last night, then obviously we didn't draw that conclusion, but we should have from taking a look at that activity. All right. So a growth equation has to increase, and we saw that that's associated with a b value that's bigger than 1, right? Whereas something decays if its b value is less than 1, and that makes sense with the word problems that we talked about yesterday. Remember, we would take 100% and add on if we were growing, and we would take 100% and subtract off if we were decaying. So that's why we're bigger than 1 and less than 1, like 100% or more, 100% or less. So as you look at 28, which number is the b value? 2. Is 2 bigger than 1 or smaller than 1? So 2 is bigger than 1, so this must be growth, right? Okay. Look at number 29. What's the b value? 0.68. Is that bigger than 1 or smaller than 1? Smaller than 1. So this must be decay. 30. What's the b value? Kind of a trick question. Can the b value be x in y equals a b to the x? No, right? Where does x have to be if we're going to be an exponential function? In the exponent, right? If x isn't the exponent, we don't have an exponential function. There's no point in talking about growth and decay if it's not even that kind of function, right? That's like saying, here's a circle, what's its slope? What? A circle doesn't have a slope, only lines have slopes. Does that make sense? Yeah? So we wouldn't answer the question, is it growth or decay, if it's not even exponential. So this is neither. If x isn't the exponent, this is an irrelevant question. Okay? So it's not exponential. What about this one? What's the b value? 0.2. Is that bigger or smaller than 1? That's smaller than 1. So what kind of problem is this? Decay. So that's how we do that. Everybody's good? Yes? All right. So let's take a look at the thing that we haven't really talked about yet, which is this idea of compound interest. So there's this fancy formula that if you were in like Excel Algebra 2, I would expect you to memorize. But you're just in Algebra 1. This is your first introduction to exponential function. I don't expect you to memorize this formula. If I want you to use this formula, it's going to be given to you. And it's given to you in your book, right? So it's like you just flip back a page and there it is in the book. But you do need to know how to interpret it. And conveniently, the book does define all those variables for you. It tells you that A, that capital A, stands for the amount of money. So like the amount of money in your bank account at any given time. Okay, that's what A stands for. A is for amount. P stands for principal, not like Mr. Barnes. Okay? Principal is like the investment, the amount of money that you put into your savings account, or the amount of money that you invest in the stock market. So the principal is the amount of money that you start with. Okay, that's what P stands for. 1 stands for 100%, but it's a number anyway, so you don't really care what it stands for. But it stands for 100%. R stands for the interest rate, because compound interest problems are like you put some money in a savings account, how much money do you have after a certain number of months? So R is the interest rate. Now, if somebody tells me that the interest rate is 3.2%, am I going to write 3.2 where R is? Do we do calculations with actual percentages? No. So how would I put 3.2 in for R? .032, right? I would have to take that percent and convert it to a decimal. So I would be pointing in .032 for R. Now N, notice N is actually in 2 places. N divides R, but N also multiplies T. That's not a mistake. It's really supposed to be in both places. And it means the same thing in both places. This is what we call the number of compounding periods. So we have to know what they're talking about. So if you have a credit card and you buy some stuff on your credit card and you don't pay off your balance, then they charge you interest. And typically the interest either compounds daily or compounds continuously. We'll work with daily because we don't have the formula in Algebra 1 for continuously compounding interest. So basically what that means is every single day, your credit card company calculates how much interest you owe them and adds that onto your bill. And then tomorrow it does that, and then the day after that it does that, and the day after that it does that until you pay your bill. Does that make sense to everybody? Yes or no? Yes? Okay. So when interest compounds, it can compound once a year, once a month, once a week, once a day, once an hour. Like whoever's loaning you the money, they get to decide how often they want to compound the interest. And the more often they compound it, the more money you owe, is pretty much how it works. Okay? So that's what the N is. So if it's compounded daily, okay, this is always like how many times per year. N always stands for how many times per year. So if it's compounded daily, N would be 365. If it's compounded monthly, N would be 12. Everybody okay? Yeah? And then T is the time in years. So how many years have gone by that this interest has been compounding? Yeah? Okay, and this always presumes that you're not making payments during this time. The problem gets really complicated if we try to figure in making payments. We won't ask you to do that in Algebra 1. It's a little bit beyond your level at this point, okay? So that's the formula we're supposed to use in 18 and 19. So I'm going to do 18 with you, and then you're going to try 19. Everybody's good? Yeah? All right, so it says, find the balance in each account after the given period. So $20,000 deposit, earning 3.5% interest compounded monthly after 10 years. Okay, so the $20,000, which variable should that go in for? P, right? That's the principal. So we're going to say A equals $20,000 times 1 plus. All right, what's the interest rate? 3.5%. Okay, 3.5% goes into the formula how? 0.035. All right, it says compounded monthly. So what's N? How many times per year is monthly? 12. So there's 52 weeks, there's only 12 months. Okay, so 12 is going to be my denominator, but then my power is going to be 12 times the number of years, because T is always done in number of years. How many years in this problem? 10. So this is just a really fancy arithmetic problem. Until you get to the end of Algebra 2, or actually probably for most of you guys at the beginning of pre-calc, you can't solve for anything other than A. You don't really have those abilities. So it's always just going to be a plug and chug, we call them problems. You plug the numbers into the formula and get an answer. You do have to be really careful with entering those numbers into your calculator. Make sure you follow the order of operations. So everybody grab the calculator that you use on a regular basis and use your calculator to calculate what this should be. And we're going to compare our answers, because if you don't get the same thing as me, it means you're doing something wrong in your calculator, and we need to identify that. So make sure you're following the order of operations. If you don't, it won't work out. When you get done, check my answer, see if it matches your answer. Questions for me? All right, so try number 19. We just did 18 together. You try 19 on your own. All right, are you ready for me to unfreeze so you can see? No? All right, what does quarterly mean? 4 times per year, right? Like 4 quarters in a dollar, 4 quarters in a year. So that's what your math should look like, and that's what your answer should turn out to be. What would annually mean? Every year, so just once a year. What would semi-annually mean? 2 times during a year. Yeah, semi-annually would be 2 times. Quarterly is 4 times. So pretty popular money terms. You hear that come up a lot. Like people have to file, if you own a business, you have to file your taxes quarterly, 4 times a year. It's just the way it works. All right, any questions about that? Are we good now? We know what we need to do? Okay, so next is going to be a little activity, which I am pretty sure is in your packet, but off the top of my head, I'm not sure what page it's on. So can you find this page in your packet, please? It's the very next page? That would make sense. I'm glad it's in logical order. Okay, so go to this page. So this is your in-class activity. Yep. Hold on, I can't write apparently. If you don't finish it up, it becomes your daily practice. Okay, so your goal is to get this done before you leave today. Now, while you are working on this in your usual assigned groups, in your usual assigned places, have your bookwork out, because I'm going to walk around and give you credit for having that bookwork done, and that way I don't have to remember to check it on Monday. Does that make sense to everybody? Yeah? So leave your bookwork out, get with your groups, and complete this activity.